Hi everyone, welcome to another one of our short video series. In this video, we'll learn about thin lens. By the end of the lesson, students should be able to understand what causes light to converge in a converging lens and diverge in a diverging lens. We will also discuss applications of lens. What is a converging lens? A converging lens, or convex lens, as it is sometimes called, is a glass that is thicker in the middle and thinner at the edges. A converging lens brings parallel rays of light to a single focus point. That is, it converges parallel rays of light. A diverging lens is a lens that spreads out light rays that are initially parallel, making them appear as if it is coming from a single point on the same side of the lens as the light source. It is also called a concave lens because it is thinner in the middle and thicker at the edges. Because the surface of a lens is curved, parallel rays of light hitting different parts of its surface would have different incident angles, and hence different refracted angles. To convert parallel rays of light to a single point, light ray that is furthest from the middle bends the most, whereas light rays nearer to the middle bends less. You can imagine that a lens is made of prisms of different sizes, and the incident rays have different incident angles. There is no refraction occurring in the middle of the lens. Here is something for you to think about. If we model a lens as one that is made of different prisms, does dispersion occurs? Lenses are used in optical instruments such as cameras, spectacles, microscopes, and telescopes. Let's take a look at some common applications. Lenses are used to correct vision. Here we have a situation where a person is short-sighted. What short-sighted means is that the focal length of the eye is too short. As a result, the image is formed in front of the retina, which is the light-sensitive tissues lining the back of the eye, or what we call photoreceptors. To see clearly, the focal length should be about the diameter of the eyeball. How do we correct the vision in this case? We have to make use of concave lens. What the lens does is that it broadens the light path, and when the broader beam enters the eyes, the image is projected at the rear where the retina is. The other instance is where someone has a long sight. The opposite is true, meaning that the focal length is too long. The result is that the image forms behind the retina. Pause and take a moment to think about what we need to do to correct the image. Yes, that's right. We need to narrow the light path, and that can be achieved using a convex lens. The narrower light path will cause the image to move forward, resulting in the image being formed at the retina. That's all for this video. Be sure to check out our other videos.